Greetings and salutations, professional nurses. Mrs. Ignacio here with our nursing huddle. Today we'll be discussing dosage calculation. This review is designed for those that may not have any experience with dosage calculation or those in pharmacology, nursing 100. So let us begin. So there's going to be 4 basic methods for calculating drug dosages: basic formula, ratio and proportion, fractional equation, dimensional analysis. So the basic formula is probably what most students will use. Ratio and proportion is my favorite. Fractional equation, I haven't really seen it used that much, but we'll mention it briefly. And there are some students that are diehard dimensional analysis fans, and that's totally fine. Math is going to be something that can be perceived in different ways by different people. So choose the way that works best for you and then stick with it. So let's just jump right into our basic formula. That's going to be method 1. The formula to memorize is going to be D over H times V will equal the amount of medication to give. D equals the dose that is ordered by the physician, and we will be doing some sample problems, so don't worry about that. So D equals the dose ordered by the physician. H is the dose that is on the label of the container. And V is the form and the amount in which the drug comes. Does it come in tablets or capsules? Does it come in mLs, right? So that's what we have to realize for the formula. So we have to be able to identify those things. I have seen at one point, I had a student that really did a great job as she was going through the test. She highlighted with highlighter the important values so she could just readily plug them into the formula. And that might be something that may be helpful to you. All right, so let's continue on. So here's our first problem. What is ordered is erythromycin 0.5 grams. PO means by mouth. Q8H, that means every 8 hours. And I'm just reviewing these terms because some of you may not know what these terms mean. Okay, so the drug available, that means this is how it comes. It's 250 milligram tablets. So if I have 1 tablet, that is going to give me 250 milligrams of erythromycin, which is an antibiotic. So the first thing that we have to do is convert those grams, those 0.5 grams into milligrams. Okay, so we will do that by moving our decimal spot to the right because we're going from a greater unit of measurement to a smaller unit of measurement. So the number is going to be larger, okay? So once we move those decimals, excuse me, to the right, we will see that we have 500 milligrams, okay? So 0.5 grams equals 500 milligrams, okay? So 0.5 grams equals 500 milligrams. And just to make sure that you understand what's going on here, we moved our decimal from between the 0 and the 5, we moved it 3 spaces to the right, and that's how we got 500 milligrams. All right, so now that we know what the doctor has ordered in milligrams, we will solve using this basic formula. So D over H equals V. So D in this case is going to be the converted form, which is 500 milligrams. That is what is desired to give to the patient. And H is what it says on the label. So 250 milligrams is what we're going to put. And then V will be the vehicle. How does it come? And we know that this is tablets. So we will do the calculation. 500 divided by 250 times 1 equals 2 tablets. Now, one thing about this PowerPoint, it does not put the units. I always put the units because I want to make sure that the units cancel. And once the units cancel, I know that I have done this math problem correctly. So the solution for this problem is going to be that I will administer 2 tablets for this patient, and that is Q8 hours. A twist you could see for this kind of problem is if I have to give 2 tablets every dose, how many would I have to administer in a 24-hour period? Right? So these are things that you have to make sure that you're reading very carefully when it comes to solving these problems. All right, let's go to problem number 2. So we have ordered is Lorabid 0.5 grams, PO by mouth, Q 12 hours. So that's every 12 hours. What is available is 200 milligrams per 5 mLs. Okay, so this is not going to be tablets as the last problem was. This is a liquid medication. So you may remember from the last problem, we cannot keep grams. We have to work with like units, and we will change or convert the 0.5 grams into milligrams. I will move my decimal spot to the right 3 times, or you can multiply 0.5 grams times 1,000. Either way, you're going to get 500 milligrams. And that is the value that we're going to plug into our formula. So remember, the formula is D over H times V. So the desired is 500 milligrams because we converted those grams, remember. And then what's on the label is the H, 200 milligrams, and the vehicle is going to be, it's going to be in 5 mLs. So that's why 5 mLs are there. When we divide 500 by 200 and multiply it by 5, we get 12.5 mLs. So the answer is going to be 12.5 mLs. Make sure when you are doing your dosage calculations, especially if it's written on paper, that you include your units, because if you do not include your units, then it will be marked incorrect. When you are performing these calculations for your test on ExamSoft, only put the number because the unit is already written as part of the question. So if you put the unit, the system for ExamSoft will probably mark your answer incorrect. Okay, so you always want to include the units when you are doing this on pencil and paper test. And the other thing that's important is to always show your work, because that way your instructor can see where you went wrong. Okay, all right. Let's do a third problem. We have, and we're still using the formula. Okay, we're doing method 1. So we have ordered phenobarbital 120 milligrams stat. Stat means I must give this medication right away. The drug that is available is phenobarbital, 30 milligrams per tablet. So we'll use our basic formula. D over H times V. What is desired is 120 milligrams to be given stat. What does it say on the label? 30 milligrams per tablet. So we have 30 as the H, and then the vehicle is going to be one tablet. So 120 divided by 30 multiplied by 1 will give us will give us 4 tablets. Okay, now we will give the patient 4 tablets stat, so right away, okay? 4 tablets. All right, hopefully this is making sense, and we will go to our 4th problem with our method 1 using the formula D over H times V. So we have Demerol, right, or meperidine that will be given to our patient. 35 milligrams IM means intramuscular stat, means right away. So I'm going to be giving an intramuscular injection right away. How it is available on hand is going to be 50 milligrams per ml. So that's 1 ml. Okay, so D over H times V. 35 is what's desired. 50 is how it comes. And then the vehicle is going to be 1 ml. So when we do the calculation, we will have 35 divided by 50 times 1 gives us 0.7 mLs. Okay, so the answer for this is going to be 0.7 mLs. So you may notice that this is a medication, the answer that it's rounded to the nearest tenth, right? And I want to emphasize tenth. So usually your exam questions will say what you need to round to, okay? And I know this one did not specify, but your exam questions should specify if you're rounding to the nearest tenth. Okay, one thing to keep in mind, I know we're not getting to that yet, but if you have a drop factor question, you have to round to the nearest whole number because you cannot have a fraction or a decimal of a drop. Okay, that's going to be one thing that you have to keep in mind when we get to those drop factor questions. All right, let's now go to method number 2, ratio and proportion. So this is my favorite because math is something that I find challenging sometimes, but it helps me to keep everything lined up. And when my units cancel, I know that I have gotten the correct answer. So when we talk about ratio and proportion, we have H, which is on hand, V is the vehicle, and that's what we know. Now, the desired is going to be the D, desired dose. What did the doctor actually ordered? And then we have to solve for X. Well, how much of this medication do we have to give? Okay, so with this, we're solving for X. Okay, so let's look at a problem and figure out how we could actually set up this ratio and proportion. So this is the same problem, and it says erythromycin 0.5 grams PO by mouth Q 8 hours. So every 8 hours we must give this medication. What's available or how does it come? It comes in 250 milligram tablets. So the first thing we have to do, which is the same thing that we did in the first way we solved it, is changing 0.5 grams to, or converting it to 500 milligrams. So that is multiplying 0.5 grams by 1,000, or you could move your decimal spot 3 times to the right. Either way, you will get the correct answer of 500 milligrams. That's your conversion. So now we will set it up. 250 milligrams equals 1 tab, which equals 500 milligrams by, and we'll solve for X amount of tabs. So once we do this, we will actually end up with X equaling 2 tablets. 2 tablets. Okay, 2 tablets. All right. So when we look at this problem, we will fill in the blanks of this ratio and proportion. And so the H is what's on hand is 250 milligrams. And then the vehicle in which it comes is going to be in 1 tablet because that is what we know. That is how the medication actually comes. On the other side of the equal sign is what we desire and what we don't know, right? We know that it's ordered 750 milligrams by mouth every 8 hours, but we don't know how many tablets we have to give. And that's when we solve for X. And in this case, X equals 3 tablets. X equals 3 tablets. So every 8 hours, I will give my patient 3 tablets so they can receive 750 milligrams of erythromycin. Okay, so that is just a little further explanation. All right, let's go to the next problem. We have valproic acid or Depakine, 100 milligrams PO by mouth TID. TID means 3 times a day. If you saw BID, that would be 2 times a day, okay? So the drug is available in 250 milligrams per 5 ml, and this is an oral suspension. Fun thing to know about suspensions, this is going to be the one medication that you want to shake vigorously because it tends to separate. So that's just a fun fact for you. So using this ratio and proportion, we know that Depakine is available in 250 milligrams over 5 mLs. We'll write that first. What's desired to give to the patient is 100 milligrams, and then we have to solve for X, and we're trying to find out how many mLs we need to administer to the patient. Once we plug all the numbers in, we cross multiply, we get X by itself. X equals 2 mLs. So I know that I will be administering 2 mLs of this oral suspension 3 times a day. So this question could also ask you, how many mLs will I give in a 24-hour period? Well, I know that it's given 3 times a day, so I must multiply 2 times 3, and that will give me 6 mLs. Okay, so make sure you're always reading carefully what the question is asking you for. Okay, oh, let's go back. So here's problem number 3. We're going to, what's ordered is atropine, so we're going to administer atropine 0.6 milligrams IM intramuscular stat. So right away, we'll be giving this intramuscular injection. What's available is 0.4 milligrams per ml. So in every ml, there's going to be 0.4 milligrams of medication. So let's go ahead and set up our ratio, 0.4 milligrams over 1 ml, because that's what we know. That's how the medication comes. What's ordered is 0.6 milligrams, and we have to solve for X. We'll cross multiply, get the X by itself, and then we get 1.5 mLs. So I know that I'm going to administer now 1.5 mLs of atropine intramuscularly right away for my patient. Okay. All right. Let's go to our method 4 of dimensional analysis. And this is kind of a long way to put everything together. And all your units cancel as well, right? So this calculates the dosages with 3 factors. The drug label factor, right, is the form of the drug dose, which is going to be equivalent to V, with its equivalent units, which is H, right? Could be capsules or your milligrams, right? For one capsule, there's 500 milligrams. And then there's a conversion factor. So you do have to memorize these conversions. So every 1 gram equals 1,000 milligrams, and every 1 milligram equals 1,000 micrograms. So the drug order factor is going to be equal to D. All right, so here's how we set this up with our dimensional analysis. The form of the drug times, so V times D all over H times 1, or it could be blank. So V is the form of the drug, D is the desired dose, and H is what's on hand. Okay? So, and then you have the formula on the bottom using the conversion factor if that is required. So let's take a look at some of the problems that use dimensional analysis. Okay, so here is the problem. Erythromycin, 1 gram PO by mouth Q 12 hours. So what's available is 250 milligram tablets. The drug ordered and the dosage on the bottle are they're in the metric system, but the units are different. Well, we know that we can't keep grams. We have to actually change grams or convert grams to milligrams. And we can do that, right, by multiplying 1 gram by 1,000 or moving that decimal spot 3 places to the right. And that will give us 1 gram equals 1,000 milligrams. Now that you have milligrams, you can solve using this dimensional analysis. So in order to figure out how many tablets we give to the patient, we have our tab times 1,000 milligrams times 1 gram, and then we divide that by 250 milligrams times 1 gram times 1. Once we do that calculation, we will end up with 4 tablets. We will end up with 4 tablets. Okay, let's go to our next problem. And this is spelled out a little bit more. So if you do like dimensional analysis, also if you follow the Kathy Parks dosage calculation videos, she prefers to use dimensional analysis. Okay, so problem 2, acetaminophen or Tylenol, 1 gram PO/PRN. So remember, PO is by mouth, PRN is as required. The drugs that are available, right, how the medication comes, what's on the label is 325 milligram tablets. So you have to, of course, change that 1 gram to milligrams, right? And PO is by mouth, PRN is as required or as needed by the patient. So we will fill in our blanks and to get the amount of tabs to administer, 1 tab times 100 milligrams times 1 gram, right? And then all over 250 milligrams times 1 gram times 1. And then we will get the answer of 3 tablets. 3 tablets is what we will administer to the patient. All right, let's look at our last problem with dimensional analysis. We have ciprofloxacin, which is also known as Cipro, 500 milligrams to be given PO by mouth Q12H. So every 12 hours. So what is available is 250 milligram tablets. So we'll solve using dimensional analysis. 1 tab times 500 all over 250 milligrams times 1. Once we do that calculation, we will actually get 2 tablets. So every 12 hours, I will give my patient 2 tablets. I think I said 12 tablets, but 2 tablets. So every 12 hours, I will give my patient 2 tablets. The question could ask, how many tablets will I give in a 24-hour period? So if that's the case, I would multiply 2 times 2 because I'm going to give this medication twice in a 24-hour period. All right, that was an introduction of how to solve these basic problems. So let's now actually do some problems. So we'll focus on problem number 1. I will give you some time to work through it, and then I will do the problem on this document. So question number 1. A nurse is preparing to administer morphine sulfate 2 milligrams IV bolus. Available is morphine sulfate, 10 milligrams per ml. How many ml should the nurse administer per dose? Round the answer to the nearest tenth. Use a leading zero if it applies. Do not use a trailing zero. I will give you some time to set this problem up, and then I will solve with you. Okay, so hopefully you have been able to set this up. Let's write the formula in case you're going to be using the formula. So that's D over H times V, and that's going to be equal to the medication that we need to give. So if you choose to use the formula, we can set it up and work it that way. All right, so D is what is desired. What did the doctor order for the patient, which is 2 milligrams? Okay, and what's on the label is 10 milligrams. And how does it come? Or the vehicle is, oh, I'm sorry, the vehicle, and that is going to be 1 ml. So once we work this out, 2 divided by 10 times 1, we get the milligrams that cancel. We get 0.2 mLs, and that is going to be your answer. Okay, notice the answer said round to the nearest tenth. 2 is my tenth. Okay, now if we did this calculation, for example, and we ended up with 0.21 mLs, we would write the answer 0.2 mLs because we will round to the nearest tenth. If we did the calculation and we got 0.25 ml, because the answer says round to the nearest tenth, the answer we would give is 0.3 mLs because we have to round to the nearest tenth. Okay, if you have 0.25, that is actually not the nearest tenth, that is the hundredths place. So make sure that you're reading correctly so you don't miss a problem. Okay. So if you were to do the ratio and proportion method, let's erase this. Okay, we'll erase this and set it up as ratio and proportion. On the left side, we're going to put what we know. Okay, so I know that this medication comes in 10 milligrams over mLs. And now we have ordered 2 milligrams. So I'm going to solve for X because I don't know how many mLs I will have to administer. So I will cross multiply. That's what these arrows mean. And what does it look like when I cross multiply? Well, I have 10 milligrams times X. Okay, and then I will multiply 2 milligrams times 1 ml. The next step is to isolate X because we have to solve for X. We want X to be by itself. So we will divide both sides by 10 milligrams because what you do on one side, you have to do on the other side. And I prefer this method because my milligrams will cancel and I'm only left with mLs. And once I do the calculation, I know that X is going to be equal to 0.2 mLs, and that is the answer. And again, I double check because it says round to the nearest tenth, and that's what I have done. All right, so we're going to pause here, and I'm going to get set up for my next problem. Okay. So the next problem reads, a nurse is caring for a client who has schizophrenia and is experiencing hallucinations. The provider prescribes chloroprom- chlorpromazine, chlorpromazine 50 milligrams IM every 4 hours as needed. Available is chlorpromazine injection of 25 milligrams per mLs. How many mLs should the nurse administer? So something that I should have done just as an example for the first problem, but I'll do it now. I'll highlight the information that we need to solve for the medication that we will administer. So we have the medication, chlorpromazine, 50 milligrams is going to be given IM Q 4 hours, okay, as needed. So that's going to be PRN. But the number that we need to focus on is 50 milligrams. The injection is available 25 milligrams over mLs, right? So let's go ahead and set this up using our formula. And the formula is D over H times V gives us the answer. So what's desired is going to be 50 milligrams. On the label is 25 milligrams, and it comes in 1 ml. Once you do that calculation, you should get 2 mLs, okay? 2 mLs. Let's erase this now and we'll set it up with our ratio and proportion in case that's how you prefer to do it. And I'm not doing dimensional analysis just because that is not my strong suit. So I'm going to stick with what I know. And I just want to emphasize that Kathy Parks, she does dimensional analysis, and so does registered nurse RN. They use dimensional analysis. Okay. All right. So I'm setting up 25 milligrams over 1 ml because that's how the medication comes. The doctor has ordered 50 milligrams. Notice both milligrams are both on the top, and now I have to solve for my milliliters. So this X with the pointed arrows means that I'm going to cross multiply, and 25 milligrams multiplied by X is going to equal 50 milligrams times 1 ml. I need to isolate X because I'm solving for X. So I will divide both sides by 25 milligrams so I can get the X by itself. And my milligrams will cancel, and then I will have 50 multiplied by 1 divided by 25, and so X is going to equal 2 mLs, and that is my answer. And this does say round to the nearest whole number, and that's what I have done. Okay. All right, let's erase this and go to one more problem of this type. Okay, so let's do number 3. I'm going to pause for a second, so hopefully you can set this up using the fractional ratio and proportion setup or using the actual formula. So I'm going to pause for a second, give you some time to actually set that up. All right, hopefully you have set this up, and let's highlight the things that's important in this. Okay, so we're going to give, right, administer 250 milligrams of this antibiotic. Available is 3 grams per 5 mLs, and how many mLs should we give? Now you hopefully noticed that, wait a minute, this is in grams, right? This 3 grams, and I can't work with grams. I have to convert those grams to milligrams. So that gives us 3,000 milligrams because I'm going to multiply this 3 by 1,000 or move the decimal spot 3 places to the right. All right, so let's set it up with our formula. And again, we have D over H times V, and that will give you your answer. So what is desired is 250 milligrams. That's what's desired to be given to the patient. We know that 3 grams is 3,000 milligrams, and it comes in 5 mLs. Okay, so once we do that calculation, I'll give you a moment to do that calculation. And let me double check my calculation. 250 divided by 3,000. Multiply that by 5. And I am going to get my milligrams to cancel. I will get 0.416666, right? So this is not my final answer because it says round to the nearest tenth. So I will round this to 0.4 mLs. Okay, so X equals 0.4 mLs. Okay, because I am rounding to the nearest tenth. Okay, I'm going to erase this. I'm going to set it up using ratio and proportion with the fractions. Okay, so let's go ahead and set this up. The medication will come in 3,000 milligrams because remember, we can't use grams. We have to always use like units. Okay, and what's ordered by the doctor is 250 milligrams. Notice the milligrams are on the top, right? And we solve for X. We will cross multiply. That's what this X arrow means. We have 3,000 milligrams times X, which equals 250 milligrams. I'm going to get cut off here by 5 ml. Sorry, that's a little cut off. We're going to divide both sides by 3,000 milligrams because we need X to be by itself. We need to isolate X because that's what we're solving for. And what we do on one side, we do on the other, and our milligrams will cancel. And so we have 250 multiplied by 5, and that is going to equal 250 multiplied by 5 divided by 3,000. That is going to equal 0.41666, right, mLs. And it tells us to round to the nearest tenth. So we will do that and we will get 0.4 ml. If when we did our calculation, we got 0.4666, we would actually round this to 0.5 mLs, okay? Because that is the rounding rule. If it's 5 or greater, we will round up. If it's less than 5, we will keep it as it is, or they say round down. All right, so those were 3 problems, and I'm going to pause for a moment to see if there's any questions. All right, we are going to look at question number 10, which is a drop factor kind of question. So the nurse is preparing to administer dextrose 5, which is D5W, 5% in water, 150 ml IV to infuse over 3 hours. The drop factor of the manual IV tubing is 10. So the nurse should set the manual IV infusion to deliver how many drops per minute. So we'll round the answer to the nearest whole number. So let's go ahead and highlight the numbers that are important. Okay. Okay. This is going to be important. Okay. So the formula that I have written here is the what we need to use when we're performing drop factor calculations. The volume in mLs over the time in minutes multiplied by the drop factor. Keep in mind the drop factor will always be given to you. So that's nothing that you ever have to figure out. Typical numbers for drop factor can be 10, 15, 20, 30, or 60. Those are the numbers that you'll typically see for drop factor. So let's go ahead and fill in our formula. So the volume is going to be 150 mLs. The time that's given to us is 3 hours. Well, we can't use hours. The time has to be in minutes. So we must multiply 3 by 60. So we will multiply 3 hours by 60 because there's 60 minutes in an hour, and we will get 180. That doesn't really look like an 8, does it? So we will get 180 minutes, okay, times the drop factor, which is 10 GTT. GTT is the abbreviation for drops per ml. When we do this calculation, and I will do it again, 150 divided by 180, that gives us 0.83333, right? And then we will multiply that by 10, and we will get 8.333. The threes go on forever, right? GTTs per minute. But we're not done yet, right? Because we know that we cannot have a decimal or a fraction with drop factor. We have to round to the nearest whole number. Okay, so since it's 8.333, we know that we can round to 8 drops per minute. Okay, and that is going to be your answer. And I guess I should have been using the lines this whole time, but 8 drops per minute. Okay. All right, I'm going to go ahead and scroll up. Let's erase this actually, and we'll look at one more problem in this meeting today. We'll look at number 11. Okay, number 11. I'm going to give you some time to look at it, to highlight the important numbers, to kind of think it through, and I will come back and see what we've done. All right. So hopefully you're able to set this up okay. Let's remind ourselves of the formula, and I'll write it down here. Volume in mLs over the time in minutes multiplied by the drop factor. Okay, and that's GTTs over mLs. Okay, that's your drop factor. So let's highlight the important values for this one. The nurse is preparing to administer 0.9% sodium chloride, right? So that's just your normal saline, 3,000 mLs to infuse over a 24-hour period. The drop factor that's given is 10 drops per ml, right? So let's go ahead and plug these numbers into our formula. So the volume in mLs is going to be 3,000 mLs. Oh, that does not look like mLs, does it? Okay, let's try that again. 3,000 mLs. And the time that's given to us is 24 hours. Well, I can't use hours. I have to convert that into minutes. And how do I do that? I multiply 24 by 60, and that gives me 1,440 minutes in a 24-hour period. Then I have the drop factor. The drop factor is always given. It is 10 drops per ml. I will perform this calculation and I will do it again. 3,000 divided by 1440, and then I will multiply that by 10. And the answer that I get is 20.8333, right? So let's go ahead and make sure that we are rounding to the nearest whole number. So this answer is going to equal 21 drops per minute. The reason why this becomes 21 is because this 8 causes the 1, causes the 0 to be rounded up to a 1. So the correct answer is 21 drops per minute. All right, so nurses, today we got an introduction to dosage calculation. We looked at the formula that we use, D over H times V, and we also talked about drop factor problems. In future sessions, we will go deeper into other calculations, dosage by weight, and safe dose calculations. But I think this was a great beginning. So again, this video was especially meant for our new students that don't have any exposure to dosage calculation. Thank you for attending, and I'll see you next time.